Hello guys and welcome. Um, in today's lesson, I'm introducing a new topic, and this is trigonometry. Okay, yeah. It's a new topic, though to some of you it's not a new topic. Maybe you've heard about it, yeah, but the most of you, I think it's a new topic. Okay. Okay. So without wasting much of the time, let's dive in. Let's talk about trigonometry. What is trigonometry? What it's all about? What is it that is required to know for you to get ready for the exam when it comes to trigonometry? Okay, so let's start. Knowing the definition of trigonometry, I can say it's not important. Okay, it's just wasting of the time. In mathematics, knowing definition, mathematics is all about calculations. Even in textbooks, I don't think you can find a definition of trigonometry. Okay, but for the better understanding, let's talk about a triangle. Yeah, we can describe a triangle because trigonometry is all about triangles. Okay, so let's talk about the triangle. Okay, what's a triangle? Or let's try to describe how it looks. Okay, because it's very important under trigonometry, because trigonometry is all about triangles, the angles, the sides, and how they are made up of. Okay, so a triangle is a shape with three sides and the three interior angles adds up to 180. So under this topic, we will deal with triangles and their properties. Okay. Okay, so the three interior angles of the triangle always adds up to 180 degrees. Okay. Now let's talk about uh, the types of triangles. Okay, so types of trigonometry is all about triangles. So types of triangles. So at your level, secondary level or O level, trigonometry is all about triangles. But when you go to university, that's A level now, you won't even see triangles in the trigonometry. Okay, so let's talk about types of triangles. So there's what we call the right-angled triangles. Okay, so we have one right-angled triangle. This one is common, right-angled triangles. So what are these triangles? So these are types of triangles which one of the interior angles is 90 degrees. So one of those three interior angles is 90 degrees. So we say one of the three interior angles. When we say interior, we mean the angles inside. So in is inside. The angles outside, we call them exterior. exterior angles. Okay, one of the interior angles is 90 degrees. So the right angled triangle looks like this. It looks like this. So this is the 90 degrees they are talking about. So they are saying one of these, so we have 1, 2, 3, 3 angles. So one of these 3 is a 90 degrees angle. So they are talking about this one, 90 degrees. So to find the area under this type of triangles, to find the area we say, so let's talk about the area. So here we say area is equal to half times breadth times height. That is, A is equal to half BH. So this is our breadth, then this is our height. You multiply them by half, the answer we get is the area of this right angled triangle. Okay, so having talked about the area, what else? So under this same right angled triangle, there is what we call the Pythagoras theorem. Okay, so B will say Pythagoras theorem. Pythagoras theorem. So we've talked about the area, so now let's talk about how we deal with Pythagoras theorem under the right angle triangles. By the way, the Pythagoras theorem only applies to right angled triangles. Take note. So these 3 sides, they have got, each of these has got its own name. Okay, so let's say this is our right angled triangle. So each of these sides has got its own name. Okay, so let's say you have an angle here, the theta. Okay, so how are you going to name these sides? So the side opposite to the theta is what we call the opposite. So this is our opposite. That's the name of this side. Then the side where this 90 degrees angle is pointing is what we call the hypotenuse. Don't know how we pronounce it, but it's hypotenuse. Okay, so then the remaining side is what we call the adjacent. Okay, so that's a trick when you're naming the sides of the right angled triangle. Okay, so let's say you've been given this side, or maybe even this side, then you are asked to find the length of the remaining side. What can you do? Okay, so I think you've learned Pythagoras theorem in grade 10. So the same way you are doing it, that's how we do it. So we say hypotenuse squared is equal to adjacent squared plus opposite squared. So this is Pythagoras theorem. Okay, let's go to the next one. So we've talked about it. So under right angle triangles, we talked about two things: how we find the area, how we deal with Pythagoras theorem. Let's now go to the next one. So C is now trigonometric ratios. Okay, so trigonometric So now what are trigonometric ratios? So this is where now SOHCAHTOA comes in. Okay, in case you've heard about something like SOHCAHTOA, so that one talks about trigonometric ratios. Now what is SOHCAHTOA? So SOHCAHTOA is just a mnemonic that we used to remember how to deal with trigonometric ratios. Okay, so SOHCAHTOA. SOHCAHTOA. Okay, so this S stands for, this one stands for sine theta. Sine theta. Then this O stands for opposite. Remember we talked about the opposite. This H stands for hypotenuse. This C talks about the cos theta. Then this A talks about the adjacent. Whatever remained with this H, the hypotenuse, then this T is tan theta. This is opposite, then this is adjacent. Okay, so you need to master these. Okay, don't worry if you don't know cos theta, sine theta, tan theta. These are trigonometric ratios. You're going to understand. Yeah, you're going to understand, don't worry. So now we've talked about Pythagoras theorem. Pythagoras theorem. We've also talked about trigonometric function ratios. Trigonometric ratios. So take note. These two only applies to the right angled triangle. The right angled triangle only, okay, applies to the right angled triangles. Okay, take note. Okay, so now let's talk about the relationship between the sine and the cosine of exterior and interior angle. Angles. Okay, so here when the cos interior angle, so cos interior angle is positive, is equal to the negative cos exterior angle. Okay, cos interior angle, positive cos interior angle is equal to negative cos exterior angle. What about sine? So positive sine interior angle is equal to positive sine exterior angle. Okay, so what changes only is when it comes to cos. When the interior angle is positive, then the exterior is going to be negative and vice versa. But when it comes to sine, everything is possible. Interior and exterior. Take note. Okay, let's go to the next type of triangles. Okay, let's talk about the isosceles triangle. How about this one? So this one has got two. So one has got two equal lengths, two equal length or sides, and two interior angles, base angles are also equal. Two equal base interior angles how does it look like? So from this description, I think you even have the picture of how this triangle looks like. Okay, so two equal sides, meaning these sides are equal except this base. So if these are equal, meaning even the two base interior angles are also equal. So to indicate that these are equal, you see something like this to show that these two are equal. Okay, then even theta is here, this is equal to this one. Okay, so here we have nothing to say much. What's next is, let's just go to the next triangle. Okay, so the next one is what we call the equilateral triangle. Okay, number 3, the equilateral triangle. So how about this one? So this one, all length sides, all the sides are equal. The lengths of all the sides are equal. Okay, even all the three interior angles are equal. That's why it is called the equilateral. It's from the word equal. Okay, so everything is equal here. So it looks like this. So this is equal to this one, also equal to this one. So it's going to have two dots, okay, or 2 marks. I mean 3, because all the 3 sides are equal. So we're going to draw 3 marks here. Even 3 equal interior angles. Okay. Now since triangle, the interior angles adds up to 180, so we are going to divide 180 by 3. So 180 by 3, we are going to have 60. So meaning this is 60 degrees, this is also 60 degrees, this is also 60 degrees, since the triangle adds up to 180. Okay. So now, what's the next triangle? The last one. So the last one is what we call the Scalene triangle. Don't know if that's how you pronounce it, but yeah. Okay, so that's what we call the Scalene triangle. How about this one? So this one, this is the type of a triangle which all the sides are of different lengths and the interior angles are also different. Okay, so here nothing is equal or same. Everything is totally different from each other. Okay, so it looks like this. Sometimes it may look like this. This is different from this. This is also different from this. Okay, this angle is different from this one, also different from this one. Okay, so here this one is our A. We don't know. Let's say this is our C. Let's just name them. Then this is going to be our B. So now the opposite, the opposite of this one, we name it as small letter B. So here we name the angles. We use capital letters to name the angles. Then to name the sides, we use small letters of those same big letters of the angles. You know what I mean? So this capital letter B, the opposite of this capital letter B is the small letter b, the length. Okay, so this capital letter A, the opposite, the side is small letter a. Then this capital letter C, the opposite of this capital letter C is the small letter c, the length of this triangle. Okay, now how do we find the area of this Scalene triangle? Okay, trigonometry, I think most of the question comes from this triangle. Okay, they like braining this triangle. Okay, so you need to pay much attention. Okay, so how do we find the area? remember we talked about the right angle triangle. We said the area is half times breadth times height. But now, when it comes to scalene triangle, we don't have, we have the base, but do we have the height? No, we don't know. We don't have. Okay, so we use different method, trigonometry. Okay, so area is equal to half. Even here we use half, so half times AB sin C. So this is the general formula. Area is equal to half AB sin C. Okay. Okay, so that's the formula for area. Let me just write on the new page. So area is equal to half AB sin C. So this is the formula for area. Okay, so this is A under scalene triangle. What else? Let's talk about the cosine and sine rule. Okay, very important when you are answering the questions on under trigonometry. Okay, so you need to know when to use cosine rule and when to use sine rule. Okay, so let's start with cosine rule. When are we supposed to use cosine rule? Okay, so be attentive. So we use cosine rule when you have been given the two lengths. Okay, you've been given maybe A and B, then you don't know C. You can use cosine rule for as long as you've been also given the angles between those two sides you've been given. Okay, so we can use cosine rule to find the length of the other side. Okay, let's say for example, so cosine rule, when to use cosine rule, let's say cosine rule. So we can use this one. Let's say in an exam you've been given the triangle looking like this, then you've been given here 2 meters, even here you've been given 4 meters and 20 degrees, just an example. So here now you can use cosine rule. Okay, so why? Because you've been given two lengths, this one and this one, and apart from those two lengths you've also been given the angle between, take note, between those same two lengths you've been given. Okay, so you can't use cosine. Let's say for example you've been given the triangle looking like this, then the angle you have 20 degrees here, you also have 2 meters here and 4 meters here. You can't use cosine. Why? Because of course you've been given the two angles. I mean the two lengths. But is the given angle between those two lengths? No. It's not between two lengths because it's not here. Unless it was here, you can say it's between the two given lengths. Okay, so take note. Again, you can use cosine rule to find the angles of this triangle. If you are given the all three sides, okay, the all three sides, let's say for example you've been given the triangle looking like this, then here you have 2 meters, here you have 4 meters, then here you have 5 meters. Here you can use cosine rule to find the angles, the interior angles of the all three interior angles of the triangle. So if you open the paper, you just see the triangle with all three interior, all three sides given. Just start thinking about cosine rule. Okay, you open the paper, you just see the triangle with two sides are given, and the angle between those given sides is given. Just start thinking of cosine rule. Okay, let's now talk about the next one, the sine rule. So what about sine rule? When do we use it? When can you apply it? Okay, so we don't just use here now. There is what we follow. Okay, so you can use the sine rule to find the angle between two sides. Okay, that's if you are given the lengths of both sides and an angle opposite to one of the given sides. Okay, so let's say you have a triangle, so you can use sine rule to find the angle between two sides. Let's say you have this angle between this and this, so you can use sine rule to find this angle. If you are given this, let's say you have been given 2 meters, here you have been given, let's say 6 meters. You've been also given an opposite angle to those given two sides. Let's say you've been given this angle, or you've been given this angle. That's the only way you can use sine rule to find this one. You've been given two sides. You can find this angle. You can find the angle between two given sides, this one and this one, if you've been given any of these remaining angles. If you are given the one opposite to this one and the one opposite, we're talking about angles, so opposite to this one and the one opposite to this one. That's the only way you can use sine rule. And in the sine rule can also be used to find the length of one of the sides of an isosceles triangle, given the value of the angle opposite to that side and the length of one of the sides with its opposite angle given. What does that mean? Okay, so we said an isosceles triangle has two equal length and two equal interior base angles. Okay, so an isosceles triangle looks like this. So I was saying that sine rule can be used to find the length of one of the sides of an isosceles triangle. If you are given the value of the angle opposite to that side and the length of one of the sides with its opposite angle given. So as the sine rule can be used to find this side. Let's say, for example, this side. If you are given this angle and the length of this one or this one, you can use sine rule. Okay, so we have A, B, C. This is under what? Scalene triangle. So under scalene we have the formula for area. We discussed about this one. Then remember this A is this one, the B that one, and sine C. We're talking about this angle. You understand, don't worry. You understand when we start answering more questions, especially exam questions. Okay, so we've also talked about the sine rule. What's next? Okay, before we go to the next one, there is the formula we use. There is this formula: A over sine A is equal to B over sine B is equal to C over sine C. So this one, we use this one under sine rule. This is the formula we use under sine rule. Very, 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 very important. Master this one. I think there is nothing to master here. So A, B, C, sine A, sine B, sine C. Nothing is difficult here. So this is what we use. Okay. So remember, the small letters represents the lengths. Okay. Then capital letters represents angles. Take note. Okay. I don't want to go to the next page, but D, we have is what we call, you'll be asked to find the shortest distance. Okay, so there is what we call shortest distance. So represented with small h. Okay, so what about this one? So there's nothing much to say about this one. Let me just give you the formula when you are asked to find the shortest distance. So h is equal to A over B. So this A is the area of the triangle, of the triangle. Then B is the base length. That's all. Okay, so we are going to end here. I think you've gotten something. Okay, if you need some clarification somewhere, you haven't understood somewhere, don't worry, you'll be able to answer questions also when we start going through past papers. Okay, I don't want to be giving you irrelevant stuffs. Okay, our aim is to make you pass, to make the exam easy for you. Okay, so we are going to end here for today's lesson. See you in the next lesson.